In this video lesson, we'll be taking a look at a geometric sequence. A geometric sequence is a set of numbers that follows a specific pattern. This is found by dividing any term by its previous term to determine the common ratio. The common ratio will indicate as R in the sequence formula, where R is used as a factor or a number that is being multiplied in the specific formula below. If we look at the formula, a to the n, or a sub n rather, is the nth term. A sub 1 is the first term in the sequence. R is the common ratio, the factor that we will multiply by, and n is any positive integer. If we look at the sequence of 2, 6, 18, it will follow a specific pattern. If we take 6 and divide it by 2, we get 3. So here R is equal to 3. 18 divided by 6, we get R equals 3. There's the common ratio of R equals 3. To follow this pattern, we will now take the term 18 and multiply it by 3 to get the successive terms after that. In the next example, we have 162, 81, and 40.5. This will follow a specific pattern. 81 divided by 62, R is equal to 0.5 or 1/2. 40.5 divided by 81 is again R equals 0.5 or 1/2. So the factor here we will be multiplying by is 1/2 or 0.5. And again, if I want to find the next terms in the sequence, I would take 40.5, multiply it by 0.5 or the 1/2. Here's an example of how we find the next few terms in a geometric sequence. Let's first see the pattern. 10 divided by -2, R equals -5. -50 divided by 10, R equals -5. So now I will multiply -50 times -5, and I will get 250. Let's keep repeating this pattern. Multiply that number by -5, and I get 1,250. Again, if I multiply this number times -5, I get 6,250 to complete this particular sequence to 6 terms. To find an indicated term n in the sequence, again, if we use the formula, we will be able to find the 8th term. So a sub 8 is the 8th term of this sequence. The first term is 1/3. R, the common ratio or factor that we're going to use to multiply by, is 3, and then we're going to take it to the n minus 1. Following your order of operations, we'll take 1/3 times 3 to the 7th power, and a sub 8, or the 8th term, is 729 in that particular sequence. Second example, I'd like to find the 12th term. So that means n equals 12. Before I do that, I first need to solve for the first term of a sequence that has the 6th term is 3 with a common ratio of 2. So a to the n is 6, which is 3, rather. A to the n is 3. The first term I don't know. The constant ratio is 2. I know n because n is indicated as the 6th term in this particular sequence. So it would be 6 minus 1. If I solve for a1, I get 2 to the 5th power times a1. If I divide by 2 to the 5th power, instead of expanding that out, it's just as easy to leave it in a exponential form. And the first term of that sequence would be 0.09375. It does indeed truncate or stop, so I would use all these digits in order to get an accurate indication for this particular sequence. Now, to find the 12th term, the second thing I will do, so this will be my first step. The second thing I'm now going to solve for the 12th term. I know the first term. I know the common ratio, it's 2. And it's the 12th term I want to find, so I'll take 12 minus 1. Again, performing the order of operations here, times 2 to the 11th. The 12th term in that sequence will be, quick calculation here, is 192. Oop, I forgot the 5 on that. My apologies. So it should be 192. I hope you found this video helpful on finding a geometric sequence.